I keep talking about this concept of high density in our data centers with virtualization and with cloud computing, and how we have so much stuff crammed into such into one area. And one of the operational problems with that is failure. If a and this is a unique problem with virtualization and cloud computing, that a single failure can have an exacerbated effect with virtualization and cloud computing. And just thinking about virtualization in general, if you had a data center with 1,000 servers and one of those servers goes down, it's not the end of the world if you have one of 1,000 services down within your organization. But if you took those 1,000 services and you virtualized those into 5 hosts, which is not unreasonable, that you could take 1,000 servers and virtualize them into 5 really high-powered, very dense hosts with the supporting storage and so forth. Any outage in that infrastructure could affect a huge portion of the business or the organization. So now we're looking at, say, 20% of the organization being affected by a downtime or a failure in any given component. So we have to make sure that we pay special attention to high availability and clustering. And really, the way clustering relates to high availability is high availability just means that we have more than 5 nines of uptime. And I'm just arbitrarily giving you that 5 nines number, but that's pretty common in the industry. We talk about 5 nines, 99.999% uptime, which is really just a few hours a year of downtime. Um, the way we achieve high availability typically is through some form of clustering, clustering hosts, and we can do that with virtualization, and we could do clustering even in the cloud. We can, I'm sure that the cloud service providers do their own level of clustering, and we can even cluster our cloud nodes so that we even have another layer of clustering, and that's also considered a pretty good best practice. So we have lots of different options with clustering. One method, of course, is resource sharing. That's certainly one way we do. We could do distributed resource scheduling and compute resource scheduling, which is some cloud techniques or virtualization techniques for doing clustering. But basically, the idea behind clustering, the takeaway here is that you have multiple servers providing the same services. And in this case, with virtualization, you have multiple virtualization hosts, and you have enough of them running that if you have one of them fail, the entire infrastructure can be handled by the remaining operational infrastructure. So that's what we're really talking about with clustering at this level with virtualization. And we talked about clustering with business continuity. I talked about using clustering for business continuity earlier in the course. And really, these concepts remain the same, but it's important to understand from an operational perspective what the impact is on downtime, and that this is one of the methods we have to mitigate that. If we're going to cluster our servers, we can also cluster storage. So we can use the same concepts for clustering, that hardware for virtualization and our host machines and so forth. We can do the same thing with our storage architecture. We can use a clustered storage architecture. We can make sure we have replicants of data running in multiple places. As far as clustering, why we do that, we do it to maintain our SLAs, to make sure that we have availability to our data, to our infrastructure, and so forth. And really, the only way to meet these SLAs effectively is through technologies like clustering. And like I said, there's a lot of different methods to do clustering, but the important takeaway here is that you have multiple pieces of hardware doing the same thing. Just like you've got multiple engines on an airplane, so that if one fails, the airplane can still fly. If we have a major hardware failure in our data center, we want the data center to continue to be operational. In fact, um, one of the problems that I've seen with clustering, this is kind of, the flip side here, is I've had situations where the clustering is so good that even the operations team doesn't know that there's a failure, which seems absurd. But I've had scenarios where we had servers and infrastructure go down, and for a long period of time, and when I say long, a couple hours, maybe even a day, where the operations people didn't even know that it was down because the clustering was so seamless that no one even knew that infrastructure was offline. And I've had that happen with my customers, where my customers do these clusters. I have one customer that has that they clustered something, so it's so highly clustered that they can lose more than half of their servers and still have 100% capacity for their client base. It's a healthcare organization that wanted to make sure they had high availability and they were nearly impervious to failure. And I've actually had scenarios where servers have been down for weeks and nobody even knew because there was almost minimal impact on the on operations. So they had to implement monitoring tools to make sure they knew when those systems were down, and they also had to implement some policies and procedures because sometimes the impact was so light that operations people would retask themselves on other things they thought were more important because everything was running just fine, even with that failed architecture or failed components in their infrastructure.